This is week number 12, and our today's topic is subnetting. You can see the first slide in front of you. This is a depiction of a classroom that can accommodate 24 individuals. The small boxes are representing 24 seats in the area of 13 by 13 with whiteboard in front of the classroom. By looking at this depiction, we can see that there is room for more individuals, but since our class is of 24 individuals, only 24 can be seated at a time, and the next section or the next class can be accommodated in some later time. If we divide this portion into two, as it is depicted in the next slide, and place a whiteboard in front of each portion, we can accommodate 24 students in each portion. The same space which was utilized previously to accommodate 24 students is now being utilized to accommodate 48 students, and two simultaneous classes are being conducted at the same time. So this is a concept of utilizing space intelligently. You must be thinking that we started the topic of subnetting and we are talking about utilizing space for the classroom. This is an example of why we need to do subnetting. If we won't do subnetting in IP addresses, the space will be wasted. In order to efficiently utilize this space, we move towards the concept of subnetting. Let's see why. The first reason is that we have a limited address space. As you are pretty much aware, we have certain classes for communication. We have already studied that. Class A, Class B, Class C are usually used for communications. So we have a certain address space. When we talk about Class A, the range is from 1 to 126. 127 is utilized as a loopback address for diagnostic purpose. From 128 onwards to 191, this is Class B, and from 192 to 223 we have Class C. So there is a limit of network addresses. Now the example is, if you can see clearly the third point, we are talking about a network that has 20 end systems and it is assigned a Class C IP address. There will be wastage of around 234 addresses. Let's see how. This is the example. We have an address 192.170.2.0/24 indicating it is a Class C network address. The last octet is used for host and the last octet can accommodate individuals or hosts up to 254. So if we have only 20 end systems, 234 will be wasted. In subnetting, we borrow bits from the host portion. So if you take this example 192.170.2.0, we will borrow a bit from the last octet, the octet of host. And when we borrow from host portion, that is known as subnetting. By borrowing, we convert that particular bit into a network bit. So your subnet mask will also be affected. So here's our example. The first three portions are that of the network. The last one I have converted into 8 bits, because last portion, like the rest of the portions, is of 8 bits. We will borrow from the last portion, and the leftmost bit, the bit nearest to the network portion, will be borrowed first. The red bit is indicated, and we are borrowing this bit. Now it has become a part of the network. The value of the bit is 128. This bit has two possibilities. Either it will be 1 or 0. So by borrowing this bit, we can have two subnets. One will be 192.170.2.0 when this bit is 0, and the other possibility is that the red bit is 1. So in that case, the second subnet will be 192.170.2. If it is 1, the value of this bit is 128. So our subnet will be 192.170.2.128. So you just saw, by borrowing one bit, we can create two subnets. A whole network portion is divided into two. The first network ID is 192.170.2.0, and when this bit is 1, the next subnetwork ID will be 192.170.2.1. Now the first address of the first subnetwork, that is 192.170.2.0, will be 192.170.2.1. We call it the first usable address. The last usable address will be 192.170.2.126, and 192.170.2.127 will be a broadcast address of this subnetwork, the subnetwork 192.170.2.0. The second subnet or the second subnetwork will start from 192.170.2.128. Both of these subnetworks will have a subnet mask of 255.255.255.128. The other way of writing this is we can write the whole network ID slash number of bits in network portion. So usually this part is 24, but here since we have borrowed one bit from the host portion, it is now /25. We have seen the first subnetwork 192.170.2.0, its first usable address, last usable address, and broadcast address. Now, your task is to identify all these in the second subnetwork, which is 192.170.2.128. Finally, you can see on the screen there is an IP address 192.172.10.0, and you have to divide this subnetwork into this network into 4 subnetworks, each having 60 users. You have to perform these tasks and have to submit it by the end of the day. Thank you very much.